So my adjacent over my opposite is going to be adjacent is -1, opposite is √3. So this would be -1 over the square root of 3. Get rid of the square root of 3 in the denominator. And that is going to give me 2√3 minus √3 over 3. And giving me a final answer of the square root of 3 over 3. Now I want you to try this problem, a problem like this. So I am going to give you problem set 41. Number 6 is going to be your practice problem, and you should be checking your answer as you're doing these problems. Now the next one we're going to look at is circles, the equation of a circle. And we're going to be just looking at the standard form of the equation of the circle. Now the standard form of a circle is an equation that you have to memorize, and that's going to be x minus x1 squared plus y minus y1 squared equals r squared. Now my x1, y1 is the coordinate of the center of the circle. Is going to be your x1, y1. And your r is going to be your radius. So the problem that I'm looking at is on page 303. And it's the example 42.2. So it says find the standard form of the equation of a circle of radius 4 whose center is at -3, 3. Then write the general form of the equation. So the center is at -3, 3, and the radius is 4. So I'm going to input that into my equation, remembering that when I input it, it's going to change the sign. So this is going to become x plus 3 squared plus y minus 3 squared is equal to 4 squared, or you could write 16. That's my answer, and now you are going to try problem set 42, number 7. And then the last thing we're going to look at is your graph of sine and cosine. The graph of sine and cosine. So you should know what the standard shape of the sine and cosine curves look like at this point. So what I'm going to look at right now is if we look in our book on page 313, I'm looking at number 7 and number 8 right here. So I know that when a cosine curve, there's a cosine curve, and then this would be a sine curve. So the difference is that when the x and the y-axis are crossing, notice that the cosine curve either dips down or it's going to hit its highest point. For a sine curve, this one is going straight through where the x and y-axis crosses. Now, if from left to right it slopes up, that's a positive cosine. If from left to right it sloped down through the origin, that would be a negative cosine. Now, I'm going to actually do this problem. So I notice that this one is sloping down where the x and the y-axis are crossing. So that I already know is a negative cosine curve. Then what I want to find is the amplitude. And on this one, that's the distance between the x-axis and then this top point. And since that middle is going to be 0, because you'll see it's 4 and -4, so that means this is 0 in the center. That means that my amplitude is going to be 4. So my answer to number 7 is going to be y is equal to -4 cosine of theta. So it's a negative cosine curve, and then my amplitude right here is 4. Now, if I look at this second one, I notice that it's a positive sine curve. So from left to right, it slopes up through the origin. That's going to be a positive sine curve. And then my amplitude is just going to be right here. My amplitude is 5. So my answer would be y is equal to 5 sine of x. And that would be my answer. So now what you are going to do as your practice problem is you're going to do problem set 44. numbers 7 and 8, and those are going to be your practice problem. And this concludes the rest of the tutorial. Now you need to remember to submit your notes and also to submit all your answers to the questions that I've asked you, and that will satisfy for your extra credit. There are also other problems obviously on the test, so make sure that you know all the material, and if you need help, you ask questions. Have a great day.